So for part one, the question is the question is whether the sample is representative or not, right? So for the first part, poll all people voting age attending a local football game, right? So the question is clearly not.
They're so much better than the standard, mate.
Are you okay, sir? This is not a representative sample. Not representative. Not a representative sample because not every voter likes football, right? Because we are trying to get a representative sample of the voters, right? But if you go to a football game, and I mean, it's not going to be a representative sample because not every voter likes football, right? For part two, you have poll all people of voting age who are leaving an expensive town center restaurant on a particular evening. Again, this is not a representative sample. Right? Because because not every voter can afford an expensive restaurant, right? So, okay, so that's not part two. Part three is obtain a copy of voter registration list, randomly choose 500 names, and question each of them about their voting intentions. So this one is a representative sample, right? Right. Part three is a representative sample. Part four of question. I'm doing question one, guys. If you're just wondering what I'm doing. Part four is use the results of a telephone poll in which a television station asked its viewers to call and state their voting preference. And this is not a representative sample. Not a representative sample because not every voter may have a television, right? I know this is unlikely these days, but still, I mean, there are people who don't have telephone. I mean, you will, so I don't think, so part four is still not a representative sample. And part five of question one is asking you whether using 200 names randomly from a telephone directory and call these people. Again, it's not a representative sample. It's not a representative sample because because not every all right, because not every voter may be in the telephone directory. You know, some people, they don't like to be listed in the telephone directory. So again, part 5 is not a representative sample, right? All right, guys. So that completes question 1. Anything you like to ask me on question 1 so far? Just use the chat room, guys, please. Any questions on question 1, please, before I go to the next question? Hello, guys. Talk to me. Okay, thank you. All right. Next question is question 2. Which is this one here. I hope you have a copy of question 2 in front of you. All right, so this is question 2, part 1. Now the question is similar to question 1. So once again, we want to know whether the sample is representative or not, right? Okay, so let's see how we can do this. So part 1. Part 1 is not a representative sample. Because if you read part 1, guys, it says to determine what the average person spends on a vacation, a market researcher interviews passengers aboard a luxury cruise liner, because only the rich, only the mega rich can afford a luxury cruise liner. Right? Okay, that's part 1. Part 2, in part 2, you are asked the following question. To determine the average income of graduates 10 years after graduation, a university sends questionnaires in 2015 to all members of the class of 2005, and basis is estimated on the questionnaires returned. Okay, again here, this is not a representative sample. It's not a representative sample because the graduates are not likely to report their true income. So some people, if they earn like £1 million every year, they may think it's too posh to report their income. Whereas if some people, if they earn only say £10,000 every year, then they may feel embarrassed to tell that they're earning so little. So they're unlikely to report their true incomes. So it's not a representative sample. Now, part 3, if you read the question, guys, in front of you, it says to determine public sentiment about certain import restrictions from a particular country, an interviewer asks, do you feel that this unfair practice should be stopped? again, not a representative sample. Not a representative sample because of the wording of the question, because of the wording of the question. You see, if you read the question, guys, it says, if you read the question one more time, it says, do you feel that this unfair practice should be stopped? It kind of implies what the answer should be like. I mean, so even if people think if it is fair, the answer may be that they may say, because of the wording of the question, they may say it is unfair, right? So this is the answers to question number 2, right? Any questions so far, guys? Hello. By the way, I will put answers to all the questions from all the 10 questions. So how many questions we have? Yeah, we have 7 questions. So I will put the full solutions to all 7 questions later this week in the course website, right? Okay. All right, now let's go to question number 3. Question number 3, you have this. All right, now let me use this one for question number 3. So you have the population in question number 3 is, you have a population that consists of the following numbers: 2, 3, 6, 8, and 11, right? This is the population. Now you are choosing one number at random. So the possible outcomes, the possible outcome and the corresponding probabilities are as follows. The possible outcomes can be 2, 3, 6, 8, or 11. The corresponding probabilities are 1/5, 1 divided by 5, 1 divided by 5, 1 divided by 5, 1 divided by 5, right? Okay, so the population mean, in order to answer the first question, which is the population, to find the population mean, all you have to do is just multiply this with this and then sum them. So you say 2 times 1/5 plus 3 times 1/5, and so on until 11 times 1/5. So if you compute this, you will get it to be 6. So the answer for part 1 is 6. Now to find the population variance, right, you use the following formula. I'm sure all of you know this formula. Yeah, I'm sure you guys know this formula. So this is the expectation of x1 squared. This is 6 squared, which is 36. Now to find this guy here, you use this table here one more time. So it's gonna be 2 squared times 1/5 plus 3 squared times 1/5 up to 11 squared times 1/5 minus 36. Now if you compute this will be 10.8. All right, so the answer to part 2 of question 3 is 10.8, right? Now part 3 of question 3 is asking you, by considering all possible sample, calculate the mean and the variance of the sampling distribution of X bar. Right now, this is a little bit tricky, right? Let me show you how to do this. All right, so this is question 3, part 3, right? Now, No, you can't. I mean, to find the population variant, the question here is to find the population variance, Heng. I mean, the formula that you have written, Heng, is not is what you written is the sample variance, not it's the biased version of the sample variance. Whereas in part 2, the question is to find the population variance. So you must use this formula, all right? All right, now, all right, to part 3 of question 3. Now, the first thing you need to do is the following. You need to create a table with outcomes for, you're picking 2 numbers, right? X1 and X2. And we need to compute X bar. X bar is the average of these 2, right? So I'm going to write down all the possible outcomes, 2, 2, 2, 3, 2, 6. These are possible outcomes that you can have, right? You follow me, guys? 6, 6, you can have 6, 6 too, right? Because this is done with replacement, all right? So you can have 6, 6, all right? Then you can have 8, 2, 8, 3, 8, 6, 8, 8, 8, 11. And finally, you can have 11, 2, 11, 3, 11, 6, 11, 8, and 11, 11. So these are the possible outcomes for X1 and X2. And the corresponding values for X bar as follows: 2, 2.5. Next one is 4, 5, 6.5, 2.5, right? 3, 4.5, 5.5, 7, 4, 4.5, 6, 7, 8.5, 5, 5.5, 7, 8, 9.5, 6.5, then 7, 8.5, 9.5, and 11. So you see how I got this value. These values are the averages of these 2 numbers. So the average of 2 and 2 is 2. The average of 2 and 3 is 2.5, and so on. All right, once you created this table, the next thing you need to do is the following. All right, let me take this, keep it like this. Give me a sec. The next thing you need to do is to create a table with 2 columns. So this is question 3, part 3. The first column gives you the possible values for X bar. The second column gives you the probabilities. All right, the possible values for X bar as follows: 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, excuse me, sorry. Excuse me. All right, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the possible values for X bar, right? Okay, and the corresponding probabilities, right? You should go back to the earlier table. This is the full table of the outcomes and the possible values for X bar. So to find the probability for corresponding to 2, you need to count how many of these outcomes have 2, right? And if you do that, you will see there's only one outcomes. There's only one of these 25 outcomes have equal to 2, right? So the probability will be 1 divided by 25. And for the next one, it will be 2 divided by 25, because there are two, you see, there are two different values for 2.5. There's one here, there's one here, two corresponding to two different outcomes. The next one is 1 over 25, 2 over 25, 2 over 25, 2 over 25, right? And 2 over 25, 1 over 25, 2 over 25. And for 7, you have 4 different values, 4 different outcomes corresponding to x bar equal to 7, right? This is 1 over 25, 2 over 25, 2 over 25, and 1 over 25. All right, so this table here is extracted from this table, the bigger table, right? So this gives you the different possible values for x bar and the corresponding probabilities. Now, to find the expected value of x bar, what you do is you multiply this, excuse me, you multiply this with this, right, to find the expectation of x bar. So it will be 2 times 1 over 25 plus 2.5 times 2 over 25, and so on up to 11 times 1 over 25. So this will be equal to 6. So that's the expectation of x bar. Now, to find the variance of x bar, use the formula that I mentioned earlier, which is this one. Right, remember this formula, right? And we know this guy is already 6, so this is gonna be 36, right? Now, to find this guy, you use this table one more time. So it's gonna be 2 squared times 1 over 25 plus 2.5 squared times 2 over 25. Right, up to 11 squared times 1 over 25, right, minus 36. Okay, now if you do the calculations, this will be equal to 5.4, right? So this completes question 3, right? Any questions on this, guys, before I go to the next one? Hello, guys. And are you okay with question 3? I mean, how I did, is everything clear? Right. Okay. Thank you, guys. Okay. All right. Let's go to question 4 then. Now, question 4 is a continuation of question 3. The difference is that. Where am I? Just a minute. Give me a sec, guys. Trying to find where. So this is question 4. The question 4 is the same as question 3, but the difference is that you have to do it without replacement, right? So you see, in question 3 we did it with replacement. So in question 4 we're going to do the same thing but without replacement. So the first thing. So let me use this because this is easier to write. So this is question 4. The first thing you need to do is the following: outcomes for this and the corresponding values for x bar. All right. So this is the thing. Yes, you can, Charles. Yeah, you are right. You can use that formula to do part 3. Yeah, you are right, Charles. Yeah, okay. The outcomes are without replacement. The outcomes are as follows. Right, these are the possible outcomes without replacement, and the corresponding values for x bar 2.5, 4, 5, 6.5, 4.5, 5.5, 7, 7, 8.5, and 9.5. All right, you see here that I have used 2, 3, but not 3, 2. I have used 2, 6, but not 6, 2. All right. The reason for that is that the order does not matter here. I mean, you can, if you like, you can include 2, 3, and 3, 2, but you will get the same answer. So because the order does not matter, right? And similarly, you can have 6, 2, and 2, 6. You can have 2, 8, and 8, 2. The order does not matter, right? The next table you need to do is the following table: the values for X bar and the corresponding probabilities. The values for X bar are as follows: 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, and 9.5. These are the values for X bar. The corresponding probabilities are 1 over 10, 1 over 10, 2 over 10. You see there are 2 outcomes with 7, this one and this one. 1 over 10 and 1 over 10. All right, so this is you see what I've done. So I've done the outcome table and then this table. This table gives the values for X bar and the corresponding probabilities, right? Okay, now I'm going to compute. Now I'm going to compute the expectation and the variance, right? So let me do that. Okay. Okay. So to find the expectation of X bar, right? I just simply multiply this column with this column and take the sum. So it's going to be 2.5 multiplied by this, 4 multiplied by this, and 9.5 multiplied by this, right? And if you do the math, you get 6, right? All right, the next thing, to find the variance, you use the formula that I gave you a while ago, which is this one. Yeah. All right, now this is 6 squared, which is 36, right? Now to compute this guy here, you use the table one more time. So it's going to be 2.5 squared times 1 over 10, 4 squared times 1 over 10, right? And then next one is 9.5 squared times 1 over 10. Okay, and then you subtract 36. Now if you do the math, you will get this to be 4.05. Okay, so the variance, the expectation is 6 and the variance is 4.05. Now you should compare this with question 3. In question, you mean the means are the same. The means are the same as what we got in question 3, but the variance now is 4.05. The variance earlier was 5.4. So the variance is smaller. The variance is smaller for without replacement. Okay, the variance is smaller when you have without replacement, right? because the variance is 4.05, which is smaller than 5.04, which was the variance when we did it with replacement, right? So this completes question 4. Any questions, guys? Are you okay or not? I mean, feel free, if you have questions, feel free to ask me. Oh, yes, we just did part. Is there another part to question 4? I'm trying to figure out. Question 4, next one is question 5. Yeah, question 5. So we are done with question 4, guys. So the next question we need to do, any questions on question 4, guys? Hello, guys, talk to me, please. Any questions on question 4? All right, the next question is question 5. This is question 5, part 1. Question 5, which I mean, I assume that you have question 5 in front of you, right? And it's asking you, you have a population with 5 different numbers. The first part is to compute the population mean, right? So your population, the population you have here is, it contains these numbers 3, 7, 9, 11, 15. Okay, these are the numbers, right? So to find the population mean, all right, you just multiply, each of these has equal probability, right? So it's simply 3 times 1/5, 7 times 1/5, up to 15 times 1/5. All right, so you should do the math, this will be 9. So that's part 1. Part 2 is asking you to draw. If you read the question, guys, where is it? Just a minute. Draw 3 numbers without replacement and find the mean and the sampling distribution of X bar, right? All right, so the first thing you need to do is to have a table with 2 different columns, right? The first column are the outcomes, the second column is the X bar, right? So we are drawing 3 different numbers without replacement. So the possible outcomes are these. Once again, the order does not matter. So you can, if you like, you can change the order and you will get the same answer, right? You will get the same answer as you know, with the order, doesn't matter. All right. So and the corresponding values for X bar. Remember, X bar is the average of these 3 numbers. It's gonna be 19 by 3, 21 by 3, 25 by 3, 23 by 3, 27 by 3, 29 by 3, 27 by 3, 31 by 3, 33 by 3, and 35 by 3. Oh, did I make a mistake? Sorry, I missed out a number. I think 20, 21, 25, 23, 27, 29, 27, 31. Did I leave out something, guys, here? I think I missed out a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 19, 21, 25, 23, 27, 29, 27, 31. Oh, what's happening here? 3, 6, 3, 6, 9, 10. I don't know. I think I messed up something here. Can you check, guys, please? 25, 23 by 3, 4, 27 by 3, 5, 29 by 3, 6, 20, 29, 27, 31. 3, 9, 15. What did I? 3, 9, 3, 9, 15 is 3, 9, 11. 3, 9, 11 is 20. Oh shit. Sorry. What did I do? What am I doing? $25, 23, 27. I think I messed up something up. Excuse me, guys. I'm sorry about this. 27. This is 26. There's something wrong. Oh, sorry. I messed up here. Sorry. Let me start again. Let me start again. Let me cross this. Okay. I think I messed up. Sorry, guys. So this should be 19 by 3, 21 by 3, 25 by 3, 23 by 3, 27 by 3, 29 by 3, 27 by 3, 31 by 3, 33 by 3, and 35 by 3. All right. I'm sorry about this. Okay, so this is the first table. The second table that you should have is the possible values for X bar and the corresponding probabilities. Okay, so the possible values for X bar are 19 by 3, 21 by 3, 23 by 3, 25, 27, 29, 31, 33, and 35. These are the possible values for X bar. The corresponding probabilities are 1 over 10. So for the first one, 1 over 10, 1 over 10, 1 over 10, and this is 2 over 10, 1 over 10, 1 divided by 10, 1 divided by 10, and 1 divided by 10. Okay. All right, so we got these two tables. Now we should be able to compute the mean and the variance, right? So let me show you how to do that. I mean, I'm sure you guys know that anyway. So all right. So to find the mean, the expectation of X bar, you just use this table, which I just showed you, right? You use this table. You just multiply this column with this column and sum it up. So it's gonna be 2.5. Oh, excuse me, what am I doing? Not this one. Not 2.5. I mean, it's gonna be 19 by 3 multiplied by 1 over 10, right? 21 by 3 multiplied by 1 over 10, all right, up to up to 35 by 3, 35 by 3 multiplied by 1 over 10. Right, and if you sum all of this, you will get the answer 9, right? Right, so that's the mean of X bar, right? And to find the variance of X bar, you use the formula that I mentioned before, which is this one. Right, so this is going to be the square of 9 is 81. And to find the expectation of the square of X bar, again, you use the table. So this is going to be 19 over 3 squared times 1 over 10, 21 by 3 squared times 1 over 10, then 35 by 3 squared times 1 over 10, right, minus 81. And if you do the math, you will get this to be 2.667. All right, so that completes the second part of question 5. All right, the next part of question 5 is you should go back to the question, guys. You should go back to the sheet. I mean, you should go back to the sheet, which is this one. The final, or the second final part is to do the same thing for the sample median, not the sample mean, but the sample median. All right, so what you're going to do, I know I'm running out of time, but what you're going to do is the following. So this is part 3. This is part 3 of question 5, right? So the first thing you're going to do is to have a table with the outcomes and the median. I know I'm running out of time, guys. Yeah, just give me 5 minutes. I won't take too much of your time. I know it's lunchtime, but so these are the possible outcomes, as I said before. These are the possible outcomes of when you draw 3 numbers without replacement. These are the outcomes that you are getting. Okay, and the median, remember the median is the middle number. So it's going to be 7, 7, 7, 9, 9, 11, 9, 9, 11, 11. All right, so that's the first table. The second table that you need to create is this one. You need to give the different values for median and the corresponding probabilities. So there are 3 different values for median, 7, 9, or 11. The corresponding probabilities are these ones, right? Okay. Okay, now to find the expectation, to find the expected value of the sample median, you multiply this column with this column, right? And sum. So if you do that, you will get the expected value to be equal to 9, which is the same as what we got before when we dealt with the sample mean. Now to find the variance of the median, you use the same formula that I had given you before, which is this one. Right? So this is gonna be 7 squared times 3 over 10 plus 9 squared times 4 divided by 10 plus 11 squared times 3 divided by 10 minus 81, which you can work out to be 2.4. All right, so this completes part 3. And finally, finally, part 4, to finish question 4. To do part 4, you will see that the means are the same. The means are the same, right? But the variance is smaller for the sample median. Remember, the variance that we got for the sample mean was higher than 2.4. So the variance is smaller for the sample median. Right? All right, so this completes question 5. And I don't have the time to do the last 2 questions, but I will post the full solutions to all 7 questions in the course website on Thursday of this week. So you should be able to see the full solutions Thursday of this week, okay? There are three different types of full solution. There are the typed solutions, there is the handwritten solutions, and there will also be a video solution. So there are 3 different types of solutions for every example sheet. All right, you will see them on Thursday this week in the course website. Okay, guys, so have a good day. I will talk to you guys later soon. Right? Any questions, just try to, you can contact me 24/7 by email, by phone, or by Skype, or by Zoom, okay? So have a great day, guys. Any questions, feel free to contact me. அம்மா மேல வாரிய இருக்கா திருப்பி பிரச்சனையாப்பா ஓடியாப்பா wait.
Windows அடிச்சோன்னு வேணும்.